Friends, welcome to my YouTube channel. Dhanesh here. In the last video, we were discussing about the differences between one-way ANOVA and two-way ANOVA. In this video, I am giving a practical example and the different steps to be followed when you are doing a one-way ANOVA test. Here I am giving a practical example for one-way ANOVA test. Let's start. This is a quote from Socrates. An unexamined life is not worth living. Let's continue. So this is a practical example for one-way ANOVA test. Just I am giving an introduction to exploratory data analysis before that, because this is a very nice table. You can understand EDA, exploratory data analysis, is of three types. Monovariant, bivariant, and multivariant. In bivariant, there is numerical. Variables are of two types, numerical and categorical. There can be categorical and categorical, then numerical and categorical. If it is numerical to numerical, correlation coefficient, you will go for categorical to categorical chi-square test, and numerical to categorical, you have t-test, z-test, and ANOVA. See here, our things comes into picture. ANOVA. See, this is the, I can tell this is the third video on ANOVA. So I have a video on the introduction to ANOVA, then what is one-way ANOVA and two-way ANOVA, its differences, one video is there. This is the perfect example, a practical example I am giving you for one-way ANOVA. This is the mathematical equation for ANOVA. What is the math? ANOVA, it is the variability within the means, then divided by variability within the distribution. This is the mathematical equation for ANOVA. Analysis, ANOVA stands for, as we discussed, analysis of variance. That is ANOVA. Analysis of variance. That is ANOVA. Fine. You know types of ANOVA. It is one-way ANOVA and two-way ANOVA. Here we are discussing, an example for one-way ANOVA. How we can solve a question, like how we will do an ANOVA test, from end to end. How do we do that? See, we have three samples. First one is x1, x2 and x3. We have three samples, x1, x2 and x3. Okay, the first sample contains data 246, second one contains 357, and the third sample contains 468. Their sum, first step we need to calculate the sum. Here the sum 12, here the sum 15, here the sum 18. It's easy. Then the step one, we see this is what we have done. This is the data and we calculated sum. Then the step one, we need to state the null hypothesis and alternate hypothesis. Null hypothesis, the mean of the three samples are equal. Alternate hypothesis, the means are not equal. Simple. Now step two, calculate the variance between the sample. For that you need to calculate the x1 bar. X1 bar, how do you calculate? X1 is 246. See, you have to calculate the sum, that is 2 plus 4 plus 6. Sum, it is 12. 12 divided by 3, just the average, that's the mean, that is 4. In the same way, x2 bar it is 5 and x3 bar it is 6. You can see 15 divided by 3 it is 5 and 18 divided by 3 it is 6. So just calculated the average. Then step 2, this is also part of the step 2. Here, step 2, we are planning to calculate the variance, so this is also coming under step 2. X double bar, so we have x1 bar now, x2 bar now, x3 bar. So the average of these three, that we call it as the x double bar, that we can call it as the grand mean or grand average. So x double bar is equal to 4 plus 5 plus 6 divided by 3, it is 5. Simple. So you got it. Step 2, again, this is step 2. We are continuing. We need to form a table like this. This is x1 bar minus x double bar. Here it is x1 bar minus x double bar the whole square. Here x2 bar minus x double bar. Then it's square. Then again x3 bar minus x double bar. Then it's square. x3 bar minus x double bar the whole square. This is the table. So what is x1 bar minus x double bar? see, you have x double bar is 5. X1, what is x1 bar? 4. That is 4 minus 5, it is minus 1. So since we have, 3 rows of data, this minus 1 we need to repeat. So we are repeating 3 times. Its square becomes plus 1 because we have 3 rows of data, 3 observations in the rows. We have 3 rows of data. Then we have written minus 1, minus 1, minus 1. Then it's square. Then x2 bar minus x double bar. See, x2 bar is also 5 and x double bar is also 5. So its difference is 0 and its square is also 0. x3 bar minus x double bar. x3 bar it is 6 and x double bar it is 5. So it would be 1 and its square is also 1. Then we need to calculate the sigma of these. So sigma of x1 bar minus x, it is 3. The sigma of this, it is 0. The sigma of this, it is 3. You got it? So fine. Step 2, you understood. This is easy. Then sum of squares between the samples. This we call it as the sum of squares between the samples. We need to add 3 plus 0 plus 3. That is 6. That is the sum of squares between the samples. So the step 2, we got the sum of squares between the samples. That's really important. Now step 3, calculate the variance within the sample. The same table we need to repeat, but that is within the sample. For that we need to calculate x1 minus x bar, then x1 minus x bar the whole square, x2 minus x2 bar, then x2 minus x2 bar the whole square, then x3 minus x3 bar and x3 minus x3 bar the whole square. What is x1 minus x bar? See, you have to see here. What is x1 in our table? This is x1. The first one is 2. What is x1 bar? x1 bar, you know, here it is 4. So x1 minus x1 bar means 2 minus 4. You are getting it? That's why I have written here. It is 2 minus 4. It is minus 2. You are getting my point? That is x1 minus x1 bar. Once again, I will show you. See, these are all the values for x1. See, 2, 4, 6. So you need to calculate 2 minus average of this. Right? Then 4 minus average of x1. 6 minus average of that. So what is x1 bar? x1 bar is 4. So you need to calculate 2 minus 4, 4 minus 4, 6 minus 4. That's what we have written. That is, you can get it as minus 2, 0 and 2. And its square 4, 0, 2. Then the same process you will repeat for x2 minus x2 bar, because you have, in the table, you have x2 as well. In the same way, x3 minus x3 bar also. So you can calculate this, you will get this. Again, you will calculate the sigma of x minus x bar the whole square. This one you will get, this one you will get, this one you will get. Fine, you understood step 3. Sum of squares within the sample, you got it as 24. That is step 3. Then, that is a part of step 3. In part of step 3, the next thing is, after getting this, we need to calculate the F ratio. For that, you need to use this table. The first one is source of variation. That is, we have 2 between the sample and within the sample. That is the basic formula also we use, right? So this is the formula I have given you in the beginning itself. See, Anova is variability within the means, variability within the distribution. That's what. So based on that, the F ratio, source of variation, it is between the sample and within the sample. So you need to calculate the sum of squares, degree of freedom, mean sum of squares, and F. F ratio is this is the formula, mean sum of squares between the sample divided by mean sum of squares within the sample. We will start from here. So source of variation between the sample, sum of squares we calculated. Sum of squares between the sample, it is 6. We calculated. Sum of squares within the sample, it is 24. That's why 6 and 24. So you are familiar with degrees of freedom, because this degree of freedom, significance level, p ratio, p value, all these things are very important. I have a separate video for degree of freedom under the playlist statistics. You can watch it. So I have given, what is for different tests, how do you approach degrees of freedom, everything is given here. So the formula for degrees of freedom between the sample, it is column minus 1. How many columns we have in this table? 3 columns. That's 3 minus 1, 2. Within the sample, we have the formula that is n minus c. N is the number of observations. If n is the number of observations, n minus c. N minus c means 9 minus 3. See, number of observations is 9. I will show you the table in the beginning. See, how many observations are here? That is this 3, 3, 6, 9. This 9 observations we have. This 9 are the observations. How many columns we have? 3 columns. 1, 2, 3 columns. You got it. So 9 observations and 3 columns. Fine. So we will use that. So we will column minus 1, 2. The number of observations minus column 6. That is within the sample, the degree of freedom is, the formula is n minus c, and this is c minus 1 between the sample. So you got the degree of freedoms 2, 6. Please watch that video for degrees of freedom to get more clarity on degrees of freedom and the different formula. Then mean sum of squares means sum of squares divided by degree of freedom. Here sum of squares is 6. Degree of freedom is 2. So this is 3. Got it. Here 24 divided by 6. This is 4. Then F ratio is mean sum of squares between sample divided by mean sum of squares within the sample. What is mean sum of squares? F ratio. Mean sum of squares within the sample, it is 3. Sorry, between the sample it is 3 and within the sample it is 4. So 3 by 4. 3 by 4 it is 0.75. That is known as the F ratio. You got it. Fine. Now we have the table. This table you can get it from the internet. See, this is the F table based on the degree of freedom. So our degree of freedom, it is 4, it is for 3 and 4. Degree of freedom 4. You have 4 here. This is, degrees of freedom 6 and 2. See, this is the degree of freedom 6 within the sample and 2 between the sample. So within the sample it is 6. So 6 and 2. So this 5.14, 2 from this. So you need to take 6 and 2. So 5.14 is the tabulated value of F ratio. You got it. Our calculated value is 0.75. By using the degrees of freedom, this is for a significance level of 0.05. Please watch the video for significance level. This is the optimum value for significant level. It's really important. So for a significant value of 0.05, 5.14 is the tabulated value of F value. So it is F tabulated is 5.14 and calculated is 0.75. So tabulated is greater than the calculated value, right? So here we need to accept the null hypothesis and reject the alternate hypothesis. If tabulated is less than the calculated value, then you need to accept the alternate hypothesis and reject the null hypothesis. Got it? This is the final thing. Since, once again I am repeating, since the tabulated value is greater than the calculated value, we have to accept the null hypothesis. If calculated value is greater than the tabulated value, we will accept the alternate hypothesis. Fine, that's all. So that's all about the practical example for ANOVA. One-way ANOVA. This whatever we discussed is the one-way ANOVA. Thanks for watching. Please like, share and subscribe. Thanks a lot.